Hi, today we'll be discussing about system design. So I found this cheat sheet from ByteByteGo. They provided three specific concepts regarding to the system design. Today I want to explain that. I want to make a video on this. You can see whenever we are building any system, three factors are very important. First thing is high availability. Next thing is high throughput. Third thing, high scalability. Availability, scalability are most common factor. Other thing is the high throughput. Okay, I'll try to explain what are these, and you can see here. So high availability is ensure high agreed level of uptime. What is uptime here? Whenever you deployed any server, any applications, they should always keep running without any failure, right? If in case if the server down, in case if application is not working, then we call it as a downtime. That time is a called downtime. So if application is running properly, then that time is called uptime. So that is the difference between uptime and downtime. So whenever we are building any application as part of the system design, we should ensure that the high agreed level of uptime should be there. Whenever we are designing any system, we should make sure the system design should be designed in such a way that high availability should be there. You're getting it right? So we can see whenever the client is coming to software companies, and the architects, they will they will ensure a particular downtime. The downtime should not be less than 10 seconds, should not be less than 10 milliseconds, like that. They will define the SLA, service layer agreement. So here you can see downtime per day 8.64 second. You can see the measurements here. For example, I'm explaining 99.99% uptime means, so the downtime per day can be only within a few seconds. It will be only few seconds. That means 99.99% application will run without any failure. So that way, architects, they have to define the SLA factors. SLA, they have to come up with the SLA agreements with the clients. Or what is the uptime? Uptime, they can tell, okay, 24/7 your application will run without any issue. The downtime can be the 10 seconds max, not more than that. If that exceeds, right, then that is not a proper system design. Then that is not a proper well planned application. So we need to consider all these things. We need to keep these things in mind when we are designing a system. It is very important. There are two factors are there. RTO, recovery time object, recovery point object, RPO. The time takes to recover some failure is generally we call it as a recovery time object. Okay, should be generally client expect this time to be less. Within a less time, any failure, any damage should be repaired or recovered. Any failure should be fixed. Okay, so application should become up and running. So there should be less. We should always try to decrease the downtime. Okay, increase the uptime. Generally, common solutions you can see hot and hot warm are two solutions. So, if we take a microservices architecture, in a hot scenario, there will be single leader, and uh, it will always talk to multiple replicas. It will have a multiple replicas in case something is failed. The leader will coordinate with the corresponding replica to make that online to serve that for a particular purpose. Okay, you can see there are two order services instances running, and API gateway payment services also there. In the same way, hot warm scenario, there won't be any leader. It will be leaderless. Whenever something is down, immediately request will be propagated to the next nodes. Okay, both the scenarios will work. Generally these are both common solutions. The client will prefer any of the architecture suitable for them. Okay, principles always redundancy. If the redundancy of the instances of the services are there, then there won't be a problem of downtime. Always the servers and instances will be available for any amount of traffic that is coming to your application. You don't need to bother about that. Okay. Next thing is high throughput. What is high throughput is here? Number of requests that can be processed in given period of time. Process more requests in a given period time. If your application is able to process 10 requests per second, that is fine. If it is processing 100 requests, that is good throughput. Then we call it as a good throughput. If it is processing 1000 requests, then it is very good throughput. We achieved very good throughput. So the more requests are coming, the application should be able to handle the more load. So we call that as a high throughput. Maximum number of requests that can be processed in a given period of time is called a high throughput. Okay, queries per second. You can also call it as number of queries that can be answered per second, that can be processed per second, number of transactions per second that can be achieved. How we can achieve this kind of throughput in system design? There are two solutions you can see. You can add always a cache. Content delivery network is one of the examples. Generally, you can always store all static files and videos, static content delivery networks. Or you can always if you take the geographical location, right? Sometimes the content delivery network should be there in a geographical regions near to the region, so that all the static content will be get loaded without any issue. Only the dynamic data will be fetched from the database. You can see that. And Redis database also is there, you can see in the diagram. You can add the caches. So caching is a very good concept. If you want to achieve high throughput, you need to have a caching in system design. Identify the bottleneck, more threads, instances, spike management. You need to handle all these things uh, for bringing high throughput. Um so other thing is asynchronous processing. Asynchronous processing is sometimes for notification kind of modules. Let's say I want to notify some details to the customer once the order is placed. For notifying, you don't need to design a synchronous baser system, right? You can simply post a message and you can ignore it. The message will be processed later time, right? So asynchronous processing is also one of the architecture. You need to think when you are designing a system, when we require a synchronous system, when we require asynchronous system. You need to segregate that. For some of the functionalities, synchronous approach is mandatory, compulsory. So that means synchronous means whenever request A, service A is calling service B, it has to wait for the response from the service B until the service B provides the response to service A. Service A is depending on the service B. It has to wait. So that is called synchronous approach. Asynchronous means once we call other service, we will just forget. We will just leave it there. We don't bother about how, the response that is going to be processed by the service B. Right? It just simply posting a letter in the post box. In the same way, you will publish a message in the topics or queues and you will forget that, and consumers will listen to the events and they will process the data. Simply that way you can achieve asynchronous processing. So if you are building an application, order placing, order processing, payment processing, they require synchronous approach. But notification module, after order is placed, you need to notify the details, right? In the email or in the form of email, in the message. Then for that module, you don't need a synchronous approach. You can use asynchronous approach. So combination of both synchronous asynchronous for a better system design. If you want to achieve some high throughput, you need to consider that. High scalability, quickly extend to more volumes of functionalities with minimal changes. As I told you, response time is very important. Segregation of service responsibility, leverage load balancing, discovery capacity, planning, high availability, high scalability. How scalable it is. See, I have a microservice running. I can spin off any number of microservices whenever I want to do that. Right? Scalable. I can scale it depending on the load. Let's say if the load is getting increased gradually, I need to have a additional services, application services that handles the load. So I can spin up the multiple services. I need to have a load balancing mechanism, service discovery, capacity planning is important thing, segregation of service. All these things are very important when you are dealing with the system design. High scalability is a important factor. You need to have a service registry. All the microservices will register for the service discovery, right? Whenever the high load is coming, our load balancing mechanism with the API gateway, what it will do, it will immediately either increase or decrease the load depending on the number of load that is coming to the your traffic, that is coming to your website. If the load is very high, then it will spin up multiple microservices and it will increase the instances. That way you can actually bring the response time. You can bring very good response time. Your response time will be very less. It will meet your SLA. So you will have high availability, high scalability, high throughput. I hope you understood these solutions, right? As a system design, and thank you for listening.